Good morning to all. In the last module, we have discussed about the definition of Laplace transform, linear property of Laplace transform, and we found some standard functions Laplace transforms. Today, we are going to solve some problems using the standard formulas of Laplace transform. So let us go into solve 6 problems. I am writing this here. First one, Laplace transform of t square plus 2t plus 3. Again, second problem, L of sin square 2t. This L represents Laplace transform. And third one, Laplace transform sin cube 2t. Fourth one, Laplace transform of a function f of t, where f of t is a function defined by 0 when 0 less than t less than or equal to 2. 3 when t greater than 2. And L of sin h 3t. Sixth one, L of cos t and cos 2t. We are going to solve these problems using Laplace transforms of standard function. Okay. So first problem, we are going to solve Laplace transform of t square plus 2t plus 3. So to solve these problems, we are going to apply linear property first. Okay. So what is linear property? Let me recall that is L of c times f of t plus some d times g of t is equal to c times L of f of t plus d times L of g of t, where c and d are constants, any arbitrary constants, and f of t, g of t are any functions of t. Okay, and we should not forget that the t should be positive, because in the definition of Laplace transform itself, we are defining Laplace, we are finding Laplace transform only for the non-negative real numbers. So now, to find this L of t square plus 2t plus 3, as I mentioned before, we are going to apply this linear property. Here, what are the functions? T square is one function, t is another function, and 2 and 3 are constants, and 3 times 1 is also function of polynomial of degree 0. Okay. So if I apply the Laplace transform of the linear property, we will get this will nothing but L of t square plus L of 2 times t plus L of 3. Okay, and again we have to apply linear property, that we have to take the constants outside. So first term will be remain same, second term we will take the 2 outside. So 2 times L of t plus L of 3. Okay. So in third term also we can 3 outside this, so it will be nothing but 3 times L of 1. And to apply the formula for L of t square L of t, we already found the answer for the L of t power n in the last module. Let us recall that. So L of t power n is nothing but gamma of n plus 1 divided by s power n plus 1, provided s should be greater than 0. So here what will be your L of t square? So in the place of n you are having 2, isn't it? Then what will be this? This will be nothing but gamma of 3 plus 1 divided by s power 3 plus 1 plus 2 times t is nothing but gamma of 1 plus 1 divided by s power 1 plus 1. So 3 times L of 1 is nothing but 1. So from the definition of Laplace transform, we can calculate this L of 1, it will be nothing but 1. So now we know that this gamma function having some special property, that is gamma of n plus 1 is equal to gamma of n plus 1 equal to n factorial. Okay, so we are going to apply here. So the gamma of 3 plus 1 is nothing but 3 factorial, s power 3 plus 1 is nothing but s power 4 plus gamma of 1 plus nothing but 1 factorial. S power 1 plus 1 is nothing but s square plus 3 into 1 is 3. Now what is 3 factorial? 3 factorial, we know that n factorial is nothing but 1 into 2 into 3 up to n. So 3 factorial is nothing but 3 factorial is nothing but 1 into 2 into 3 and 1 factorial is nothing but 1. So now this is nothing but 1 into 2 3s are 6 by s power 4 plus 2 by s square plus 3. Okay. So now to calculate this Laplace transform of L of t square plus 2t plus 3, we need Laplace transform's linear property and also the formula of Laplace transform of t power n, the basic function. Okay. So now at last we found the answer. What is this? This is nothing but 6 by s square, sorry, s power 4 plus 2 by s square plus 3. If you want, you can take the LCM. If you take your LCM in the denominator, you will get s power 4, 6 plus 2 s square plus 3 s power 4. Okay. Then we are going to solve this Laplace transform of trigonometric function sine square 2t. So next, now we are going to solve second problem. What is that? Find L of Laplace transform of sine square 2t. So we have to apply the trigonometric formulas here. Why we have to? What is the necessary to apply the trigonometric formula here? Because in the last module we have found the answer for Laplace transform sin at, cos at, sin h at, cos h at, and so on. We didn't find the answer for sine square theta like and so on. So we are going to convert this into a method formula in which the square should not be there. So we know that cos 2 theta is equal to 1 minus 2 sine square theta. So we need the formula for sine square theta. So I am taking this to the reference side. 2 sine square theta is equal to 1 minus cos 2 theta. So sine square theta is what then? 1 minus cos 2 theta divided by 2. Okay. Now we are going to apply this formula to calculate the sine square 2t. Okay. So hence sine square 2t is nothing but 1 minus, in the place of theta we are having 2t. So 1 minus cos of 2 times 2t, that is nothing but cos 4t divided by 4. So now Laplace transform sine square 2t is nothing but Laplace transform of 1 minus cos 4t, because sine square 2t is nothing but 1 minus cos 4t divided by 4. Now we have to apply linear property which I mentioned in the first problem itself. So that is, we can take the constant outside, 1 by 4 outside. So balance is a Laplace transform of 1 minus cos 4t. Now again we can apply linear property to this function. So this is nothing but L of 1, L of cos 4t. So L of sine square 2t is nothing but 1 by 4 times L of 1 minus 1 by 4 times L of cos 4t. So what is cos 4t value? So in the last module we have discussed that L of cos at is nothing but s divided by s square plus a square. In the place of a we are having constant 4. So this is nothing but L of 1 by 4, L of 1 is nothing but 1, L of cos 4t is nothing but s divided by s square plus 4 square. So here I am writing this answer here. So 1 by 4 minus s divided by 4 times s square plus 4 square is nothing but 16. So 16. So if we take the LCM, we will get s square plus 16 minus s divided by 4 times s square plus 16. Now let me solve L of sine cube 2t. Again we are going to apply trigonometric formula. Here we know that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Now we want the answer for sine cube theta. So I am taking this to the left hand side. So sine cube theta is equal to 3 sine theta minus sine 3 theta divided by 4. From this, Sine cube 2t is equal to 3 sine 2t minus sine 60 divided by 4. Now apply Laplace transform on both sides. L of sine cube 2t is equal to L of 3 sine 2t minus sine 60 divided by 4. Again, we have to apply linear property. If I apply this, 1 by 4 come outside. Balance L of 3 sine 2t minus sine 60. If I apply linear property again, this can be written as L of 3 sine 2t minus L of 6 sine 60. Take 3 outside from the first term. So 3 L of sine 2t minus L of sine 60. Now we know that L of sine 80 is A divided by S square plus A square. So L of sine 2t is nothing but 2 divided by S square plus 2 square, because in the place of A we are having 2. L of sine 60 is nothing but 6 divided by S square plus 6 square. So 3 2s are 6, balance, and the denominator S square plus 2 square is 4. Here 6 divided by S square plus 6 square is nothing but 36. So 6 is common in the both terms. I am taking this outside. So 6 divided by 4, S square plus 4, 1 divided by S square plus 4 minus 1 divided by S square plus 36. If we take the LCM in the partial fractions, we will get 6 divided by 4, 32 divided by S square plus 4 into S square plus 36. If you take this 4 and 32 into consideration, this will be nothing but A. So balance 6 into A, 48. 48 divided by the denominator S square plus 4 into S square plus 36. So now we are going to find Laplace transform function f of t, 0 when 0 less than t less than or equal to 2, 3 when t greater than 2. Now we are going to apply the definition directly. By definition of L of t, L of f of t is nothing but integral 0 to infinity e power minus st f of t dt. We can break this integral into two parts, 0 to 2, 2 to infinity, because we are giving function like this. That's why we are splitting this integral into two parts. So in the interval 0 to 2, that is 0 to 2, function value is 0, f of t is 0, and t greater than 2, so 2 to infinity, this value is 3. So 0 into something 0, so first integral becomes 0, third integral, second integral is integral 2 to infinity e power minus st dt. So we are taking 3 outside, constant, so 3 times integral 2 to infinity e power minus st dt. So now 3 times e power minus st, integration is nothing but e power minus st, here constant is minus s, it will be in the denominator, and the limit is from 2 to infinity. Okay, so if we substitute the upper and lower limits, that is upper limit is infinity, lower limit is 2, that is as t tends to infinity, this term will become 0, so first limit is 0, and second term is nothing but e power minus 2s divided by minus s. So the answer will be 3 times minus into minus plus, so 3 times e power minus 2s divided by s. Now we are going to solve L of sin h dt in two ways. One, we know that sin h at is nothing but, that is L of sin h at is a divided by s square minus a square. If we directly apply this, we will get L of sin h 3t is, here a is 3, so 3 divided by s square minus 3 square, so 3 divided by s square minus 9. So if we ask 5 more questions or 2 more, we have to explain a little more that. So it means another way to find the answer for L of sin h 3t. So another way is direct definition. So sin h 3t is nothing but e power 3t minus e power minus 3t divided by 2. If we apply Laplace transform, we will get L of sin h 3t is equal to L of e power 3t minus e power minus 3t divided by 2. So apply linearity, we will get 1 by 2 times L of e power 3t minus e power minus 3t. If we split this using linear property, we will get 1 by 2 times L of e power 3t minus L of e power minus 3t. So we know that L of e power at is divided by 1 by s minus a, here a is 3. E power minus at means 1 by s plus a. So this will become 1 by 2 times 1 by s minus 3 minus 1 by s plus 3. If we take LCM, we will get s plus 3 into s minus 3, that is a plus b into a minus b is nothing but a square minus b square. So s square minus 3 square, that is s square minus 9. In the numerator, s will get cancelled, 6 divided by 2. So 1, 2, 3 2s are 6. So this answer will become L of sin x 3t. So now we come to the end. That is the last problem. Find a Laplace transform of cos t into cos 2t. To find this, again we are going to apply the trigonometric formula. So cos a cos b is nothing but cos of a plus b plus cos of a minus b divided by 2. Because cos of a plus b is cos a cos b minus sin a sin b. Cos of a minus b is cos a cos b plus sin a sin b. If you add this, you will get this formula. So cos 2t cos t is nothing but cos of 2t plus t. A is 2t, b is t. So this will become cos of 3t, cos 2t minus t is cos t divided by 2. Now we'll apply Laplace transform on both sides. L of cos 2t cos t is equal to L of cos 3t plus cos t divided by 2. We have to apply the linear property. So if you take 1 by 2 outside, 1 by 2 times L of cos 3t plus 1 by 2 times L of cos t. So we know that L of cos at is nothing but s divided by s square plus a square. If you apply this, we will get L of cos 2t cos t is nothing but 1 by 2 times s divided by s square plus 3 square. This one becomes 1 by 2 times s divided by s square plus 1 square. So this is 1 by 2 times s divided by s square plus 9. This term will become 1 by 2 times s divided by s square plus 1. If we take LCM, we can observe that s is common in both terms. So if we take outside, so we will get s divided by 2 divided by into s square plus 1 plus s square plus 9 divided by the denominator s square plus 9 into s square plus 1. If we add in the terms in the numerator, we observe that it's nothing but 2 times s square plus 10. If we take 2 outside, so 2 times s into s square plus 5 divided by denominator is s square plus 9 into s square plus 1. So this 2 will get cancelled. So balance s into s square plus 5 divided by s square plus 1 into s square plus 9. So similarly, we can solve the problems using the linear property. In the next module, we will solve the problems using multiplication by t and divided by t. Thank you.